It's a pleasure to be here tonight, and what I'd like to do for the next little more than an hour is share with you a vision that Microsoft has for the evolution of computing, not only in the personal computer, but ultimately as it affects all of the other devices in the home that you'll come to use as a consumer. I'm going to do this essentially in 4 steps. One, explain a little bit about the evolution of the Internet. It's a phenomenon that's become quite popular and is an important part of the strategy for how computing and communication will be done in the future. The second part is I'm going to talk a bit about our vision, in particular the work of my group at Microsoft, to define what we think of as better TV. After 50 years of fairly statically defined television in the United States and around the world, that mass media is about to undergo a transformation to be a digital system as well. And so there's a lot of opinions around between the computer industry and the consumer electronics industry about how that should happen, and I'll explain a bit about our view of that. Similarly, we also know that we want to make PCs better over time. And to do that, they have to have more of an appliance-like characteristic and in some sense, be even easier to use than they are today. And together, if you combine the better TV and the better PC concepts, we ultimately have the ability to come up with a strategy for true digital television. And I'll explain how that evolution takes place. Starting first with the Internet. Basically, for 10 years, Bill Gates at Microsoft had always told the people here in our company that their ultimate goal was to create systems that would create the ability to have information at your fingertips. Essentially, anything you wanted to know should be readily available. And to some extent, we've made a lot of progress in the computer side of that problem for 10 years, and computers have become more and more well-known and understood by a large part of the population. Certainly, knowledge workers use them at work, and many people have put them into their homes. But in a way, until a year or two ago, we were still very frustrated because we knew that all that information was out there, but in fact, it was like in little islands stuck in everybody's computer or stuck in different corporations, and your ability to actually access it was just not very good. And then along came the Internet, another major revolution in computing and communications, and what it's creating is the basis to actually allow those islands of information to be accessed from all the computing devices that are out there. So what we think is we're at the next stage of is the evolution of the information age. We started mass communications with the printing press. It grew in the audio domain to telephone and then to radio. In the 40s and 50s, we saw the introduction of television. And now, about 50 years later, we really think that the personal computer and its progeny will become the basis of the next mass media communications vehicles. We've also seen that there's a growing interest in the use of online information systems. Microsoft formed a joint venture with NBC a little more than a year ago to create a situation where they would be able to use their tremendous worldwide news gathering capability, which usually just gets funneled down to a very small amount of news and video that you can watch on your television at night, and try to find a way to make all that information much more available. And so we created MSNBC as a joint venture where the online part of that information would be available through the Internet and through online services. And of course, there's always a question in people's minds: do people really care? Is there really a benefit to having online access and interactivity? And in fact, a great example of that occurred early in the life of this system, which went on the air, if you will, in last fall, when Election Day rolled around in November. And we saw this huge spike in the number of people, in fact 6 times the normal daily volume of traffic. People were going to the Internet, and in fact going to MSNBC as a well-respected news source, but one that they could essentially drive themselves. They didn't have to wait for the commentator on television to get around to talking about what might be happening in a local election. Or in fact, they might never provide you the information you wanted about the local referenda that you might be interested in. And so the ability to go to the web, click on the map, click on your city, click on the bill that you're interested in, and see essentially instantaneous information, people found very compelling and something that was important to them at that time. And so we see examples like this that make us believe more and more that in the future people will want ready access to information as well as the traditional forms of entertainment. And so we set out to try to take advantage of this Internet communications phenomena and all the computers that we've essentially put out in the world today, and create an environment where, in fact, this information at your fingertips becomes a reality. If you look at the evolution of the internet from a technology point of view, it goes back about 20 years or more. And so the underpinnings of this were not technologically a surprise to Microsoft or many other companies. What did in fact surprise us was the rate at which this became a popular phenomena, starting in the early 90s. Back in late 92, early 93, the public use, as opposed to the academic and government use of the internet, was really just beginning. But it grew very, very rapidly. And by 94 and 95, we began to see online services and the tremendous explosion in the use of these internet graphical browsing systems to allow many, many people to go out and access the internet, and both for information and ultimately, in a sense, for entertainment. But in reality, as big as it's become, we're really just at the earliest stages of this becoming a worldwide phenomenon. And we are predicting that, much like a tidal wave arriving, you can see it coming. You need to think about what the impact of it's going to be, but it's going to be a tsunami that washes ashore everywhere in the world and really changes the landscape. So the internet is really a phenomena. In fact, in our mind, in the computing business, it's the single biggest phenomena to arrive since the original development of the personal computer. There are incredibly high levels of investment and interest in it. And interestingly enough, even at the levels it has attained today, we believe it's achieved both technical and, to some extent, financial critical mass. And because of that, there will be continued rapid innovation in this environment. So while the internet is not a place today where people are making a lot of money, in fact, they're losing a lot of money on the internet, it is becoming an important complement to the existing businesses that they operate. And as a result, it has this critical mass nature. So the internet really has been taking off. And of course, when you think about it, you have to realize that the internet is really a system for linking together computers. So some of these computers are the sources of information, and some of them are essentially the users of information. And if you look here at this graph, it shows just in the last essentially 3 years the number of computers that have been attached to the internet that are essentially ready to pump out information essentially at your request. 3 years ago, that was about 2.2 million computers around the world. And right now, it's up to about 13 million computers that are attached to this internet as a source for information. If you look at the other end of those wires, the ones that are in people's homes and offices, and look at the number of households, forget essentially the businesses for a minute, and look at how many people in a residential environment are actually users of the internet, this has been growing pretty dramatically even over the last 2-year period. And we've gone from about 7 million users in the fall of '95 to 17.5 million households in the United States that are connected and actually what we consider to be active users of this. Excuse me. There are actually quite a few more households in the United States that have computers and connect to online services, but this measurement was done by asking people, did they actually connect and use the internet in some sense within the last 30-day period? And that was sort of a qualifier to decide whether they were really an active user. And so we have 17.5 million households out of about 100 million in the United States today who use this at least on a once-a-month basis. And that's a pretty dramatic number. One way to calibrate that is to realize many people associate tremendous economic and media power to companies like cable companies and broadcasting companies that service households in the United States. And the largest of those, for example, in the cable business is TCI, and they service maybe roughly 14 million households in the United States. So this active internet community, which is essentially independent of any particular geography or distribution system, is actually a group of users that are active that's larger than any of the cable systems today in the United States that deliver television to people as any one company. So the internet, if you look at it, today we estimate on a worldwide basis had about 56 million users last year. It's still growing at 90% per year, so almost doubling every year. But it was actually a small environment in terms of doing business. Only about $100 million, it's estimated, was actually transacted as business directly on the internet. But if you look forward a mere 3 years, we expect that number of active users will rise to about 200 million. and that there'll be perhaps 10 billion, in many people's estimates, maybe many more billions than 10, of business transacted directly on the internet. I've already talked to some companies in the computer industry and the communications industry who, in the last half year alone, have decided to put some of their business up for their best customers or residential customers on the web. And many of them are already finding that their businesses have exploded in terms of online access, and many of them certainly have become more optimistic than even these numbers about the size of the business opportunity for doing business directly on the internet. So we think we're at we can see the shape of a new mass media forming. If you go back and look in the 20s and early 30s at the growth in the penetration of radio as a mass medium in the United States, in its first few years, it went from 3% to 10%, and then gradually, in the 7-year period, got to about half the households in the United States. If you look back to the late 40s and early 50s, which was the beginning of television, it actually had an adoption rate that was very, very similar in nature, and over a 7-year period, actually, by that time, penetrated an even greater number of U.S. households. Now, here you're looking at a United States that still is not technologically very sophisticated in terms of the user population. And so now we look just at the statistics of 94 through 96 of the PC-TV combination of online use, and we already begin to see about 11% of U.S. households last year that were using this on a regular basis. And we expect that to be growing, as the earlier curves showed, at a pretty dramatic rate. So we don't have any reason to believe that the internet, combined with, in some sense, television as a traditional media and the personal computer as a delivery system, won't in fact become the next mass medium. So if you look out to the year 2000 in the United States, and basically this scenario is being played out in most of the industrialized world, just on a slightly time-delayed basis, we expect to see about 100 million households in the United States, of which 50 million of them will be equipped with personal computers. And of that, we expect 30 million of those households to actually have those computers online and using an online service, or in particular using the internet. It's also interesting to look at what happens, particularly in the households whose demographic profile is such that people have both a full range of television-based entertainment, but also have introduced personal computers into their families. And one way that we can measure what people are doing and what that trade-off is between their use of time for traditional television entertainment and their use of the online environment as another use of their time. These are graphs actually compiled from usage patterns of the Microsoft network in the month of February this year. The yellow graph, the yellow line, the flatter one, is the usage pattern that exists on the weekends. And you can see this is essentially a 24-hour time period that goes from 3 in the morning to 3 in the morning. And so early in the day, maybe as early as 10 or 11 o'clock on the weekends, usage builds up, stays quite flat until about 11 or 12 o'clock at night, and then declines as people go to bed. On the weekdays, people still are at work, and so the peak doesn't start to build until after 5 o'clock. It actually builds to a higher total usage level and extends out to about between 11 and 12 o'clock at night, and then drops again quite dramatically. Now, it turns out time is a zero-sum thing for people, and since we can't add more of it during the day, the fact that people are going and using online services at the times that we show here mean that they're actually not doing something else. And what they're not doing is they're not watching as much television in these households as they were in the past. And in fact, just last month, for the very first time, the Nielsen ratings, which are essentially the gospel of television and advertising and how revenues are essentially apportioned in the advertising business, noted even within their sample that television viewing overall was actually declining in the United States. And at the same time, they had for the first time done a study in concert with some personal computer folks and came to the conclusion that in fact there are other examples like this that show whether they're online or just playing games or using the computers for other things, that they are in fact turning to those devices in lieu of sitting around and watching television. And so while this hasn't happened to the majority of households certainly, it's become a big enough phenomenon to be measurable even in those traditional samplings. So there are several key scenarios in terms of the usage of the internet and the kinds of things people are going there for. It started out really sort of on the bottom left corner of this chart, where really you were just in the information publishing business. We had those several million servers out there, people were pouring data into them, but there was really no way to do business or charge subscriptions or do transactions, and as a result you pretty much had to just put it out there for whoever wanted to come get it. But eventually people realized that they could put business related information, and we started to take the technology that we've been using in business, in computers, and put it on the web, essentially blending the best of the web with the best of traditional personal computing. And that's allowed many people to put email and forms and bills, bill presentment, other things on the web, and people are beginning to go there. More recently, the electronic markets are beginning to form, and that's because we have solved many of the most difficult problems of security for financial transactions and information protection in electronic commerce. And so, as I showed earlier, the beginnings of electronic commerce are really starting to happen on the web, and we expect that to grow quite dramatically. And the next phenomena that is really just at its infancy is a technology we call multicasting. This is essentially the digital network equivalent of broadcasting as we do today with television and radio. But here we're essentially sending packets that you can think of excuse me, as smart packets, and they sort of go through the wires and they find the people that want to consume them. As a result, we have the ability to put lots and lots of information into the internet or into a corporate network and let it sort of seep out to the people who actually want to consume it without occupying all the bandwidth in all the networks in order to provide that access to the information. And this is actually the beginning of a technology that lets the web, limited only by the performance of the connections that you have, become a delivery system for multimedia information. And we think that that's going to be a very important part of merging the personal computer experience into what ultimately becomes the digital television experience. Other interesting examples are beginning to abound on the web. Microsoft, along with American Express, did a joint venture we now call Expedia, which is a travel service that actually went online probably a little more than 3 months ago, and already has achieved a level to where in a given week they're billing somewhere between $1 and $2 million worth of airline tickets and hotel rooms for people who don't actually have to go through any travel agent. They find the hotels themselves, they book the reservations directly on their computer. Now if you think about it, you say, oh well, okay, that's maybe a $100 million a year run rate. Well, that's still pretty big as a travel business in most senses, and for one that's only 90 days old, it's huge. There are other examples that I've heard recent statistics on that it's estimated that this year, in 1997, 2% of all new cars sold in the United States will actually be purchased directly on the internet. People are finding that the experience of being able to do the comparative shopping, understand all of the detailed information, look and get price quotes, look at frequency of repair reports about the models, all by just clicking along, and as opposed to having to get in your car and drive from dealer to dealer to dealer and then deal with the salesman, is actually perhaps a much more painless way to go buy a car. And being able to essentially buy and click and get one delivered to you almost that easily, I think is also a tremendous indication that people are willing to use this as a vehicle to not only gain information but to do shopping. So advertising becomes an important part of the internet. It is the way people get free over-the-air television today, and many people are beginning to depend on advertising as a way to make money on the internet, much as we do in radio and television today. And so more and more companies are beginning to realize that there are people out there, that their demographic profile is an attractive one, and that these people are spending enough time on the web that these new forms of advertising are worth investing in. Now, in fact, still the scale of this is small compared to what's happening in the traditional media, print and radio and television, but it's growing quite quickly. It also has some more interesting properties for the advertiser than the traditional media does, because in fact the computer systems that are already operating in the internet today have the ability to deliver a unique web page or a unique ad on a web page for every single person that comes to that page. And so rather than have a magazine that, you open the page, there's one ad, it's the same virtually for everybody who reads the magazine. Here you can open up a particular piece of information, and the ad can be generated based on who you are, the time of day, they think your interests might be based on what you're doing. So there begins to become a tighter match between what the advertiser is interested in representing to you and perhaps your own interests, and therefore the experience becomes more interesting for both parties. So how do you think these information utilities are really evolving? Well, in a way, they're evolving such that consumers and businesses will use this technology to communicate with each other. Now, in the world that has computers deployed to the degree that it is, that may sound not too surprising. But in fact, very few businesses communicate with other businesses using electronic means. Most corporations, for security reasons and other reasons, operational reasons, have actually been computational islands. And the only way in and out of them electronically was through very, very small, well-defined mechanisms, like you could send email in, or there may be things called EDI, electronic data interchange, that allowed certain types of business transactions to break through that wall. But in fact, the consumer had almost no access to almost any business in this country or anywhere else using electronic means or their computers. So suddenly, the general populace has got their computer and is using it to go out on the web and find information. And they're becoming used to the idea that they can go out and demand access to a corporation to either do business, gain information, get warranty information, whatever it might be. So this is forcing a fairly dramatic overhaul of how corporations do their business. One, so that they can become more efficient in dealing with each other, and two, such that the same mechanisms provide them the basis in the future to allow customers to come and essentially electronically knock on your door directly and interface with your corporation. If you look at the public network and its impact on content, you find that in fact the network becomes the primary determinant to what kind of information and services you can get today. Basically, we still live in a world dominated by what we call narrowband communications, POTS, or plain old telephone service. That's a technical term. Actually, that's what the phone people call it. What we've got in this era is a multimedia personal computer that's quite capable, but in fact no way to feed it through the network with multimedia information. And as a result, we use surrogates for the network, like CD-ROMs, where you can plug those into your computer and provide some higher speed data. And so the CD-ROM industry grew up as a way to give multimedia content to computer users in advance of the day that they could really get it the way they probably would rather get it, which is click on the mouse and have the stuff flow down the wire to them. So as we look forward to this era we call mid-band, what we find is that there are some new technologies that we can use on the existing infrastructure in order to jack up the performance of these networks. Now, we still haven't gotten to where we ultimately want to get, which I'll show in a minute, to be a full broadband two-way communication network. But by taking and adding these technologies to things like adding broadcasting to the personal computer, which we have just done and announced, we're able to create hybrid delivery systems where we can send a lot of high-speed information, for example, from a satellite or a terrestrial antenna to a computer system, have it receive that, and still provide interactivity through the existing traditional narrowband environment. So here you have what the arrows kind of imply as a highly asymmetric communication system. It has a lot of capacity to push bits toward the house, but it doesn't have very many, doesn't have much potential to move them back. That leads us ultimately to what we call switched broadband. In fact, this was a technology that largely was perfected and advertised highly, hyped highly in the era 2 or 3 years ago, where people called it the information superhighway. In this time period, people thought that they could build these networks, they could build them quickly, and that the whole world would make a leap from narrowband directly to switched broadband. And Microsoft and many other companies spent a lot of money perfecting that technology, only to be stymied because the people who run the telephone companies and the cable companies at that point realized that the video on demand or movie business and perhaps shopping by themselves were not a big enough business to allow them to pay for these new networks. And in fact, they had no confidence, because it wasn't obvious, the internet wave hadn't begun to build, that there was really going to be any other generalized mechanism that would make information available to people. And so everybody stopped building those new networks. And in fact, they're only now beginning again to think about building them. So it's left us with this period in the middle, euphemistically called the mid-band period, where we are forced to take the existing mechanisms we've got and use them to speed up this delivery mechanism. So what we really see is a tremendous range of options to go from narrowband to broadband. And if you're a business or a content developer, it's important to think about the network and its effects on you. As we move in time from the narrowband world to the broadband world, we also change through that time the kinds of client devices that people have in their homes or businesses in order to access it. So basically, you've seen the personal computer grow up from a very plain type of device with a low-speed modem to where in 1997 it will be common practice to be able to buy a personal computer that will come with the integral capability to receive both digital, satellite television, terrestrial television, and all of the forms of internet communication, all as a built-in capability. And as in basically 97 and on into 98, we begin to see the introduction of cable modems and ADSL as high-speed residential data networks that you'll be able to buy from your phone company or cable company. Then, in fact, these personal computers will again rise up and begin to take advantage of this high-speed two-way communication environment. And when we finally do begin to install high-speed packet switch networks like ATM networks, then, in fact, we'll see an introduction of both interactive television services and other appliances that depend on the network for their operation. And so as all of that happens, you see a progression from traditional online services to business-oriented groupware activities and communication, to this year the introduction of the ability to watch TV and browse the web all on a common device, and then that eventually grows into this full form of interactive television, network-based gaming, and pay-per-view movies and events. So what's happening, and which you can actually read about in the popular press, you know, the business press or, you know, Wired, for example, that caters to this community, the new technologies that people are calling webcasting or the push technologies are really the digital equivalent of what emerged as the broadcast medium that we know today. And here what people are recognizing is that there's always way too much information out there for people to consume. That's true in the print media today. And what that led to is the development of magazines where you turn to editors, or to newspapers where you turn to editors to basically gather information, apply some filter to it, and ultimately you begin to trust that filtering process. But it presents to you a more packaged set of information that is likely to be of use. And that opportunity exists now not only through organizations, but through the use of software and the computer systems themselves. And so these new mechanisms of using the web as a push mechanism that allows us to take prepackaged content and deliver it is becoming an important part of creating in the digital world those same systems of editorial value add that have emerged in the traditional mediums. What this results in is essentially a progression in the use of the internet that's actually quite a bit different than that which was originally forecast 2 and 3 years ago. At that time, people were really focused a lot more on video rather than the delivery of information to computers. They were focused on starting with television instead of starting with data services. But in fact, what's happened is the internet has allowed us to start with information and perhaps education, with the addition of mechanisms for payment to move into retailing and business services. And then finally, as the networks get better and we use these hybrid delivery systems, to also use this as an entertainment delivery system. And so this is actually just backwards from what people thought as little as 2 or 3 years ago, where they thought we'd begin with essentially entertainment services like movies on demand and gradually work our way back into what was at that time an unknown world of information access for consumers. So in fact, if you look at this and you understand what's happening in computation and the internet and how all this media is converging, you do come to the inevitable conclusion that in fact the online use of personal computers and in the future intelligent televisions will actually be the next mass media. So now to move ahead and talk a bit about the evolution of these devices. At Microsoft, we have certainly always been a leader in the personal computer era. But we also recognize that we want to take our software and use it to make other appliances better. And as Terry said in the introduction, my job at Microsoft is the non-PCs. And so we actually see a broad family that go from very small devices like what Bill Gates calls the electronic wallet of the future, which is really a thing like a pager on steroids that has a communication capability, a computation capability, but also the ability to hold all of the things that you really carry around, tangible instantiations of today. You have car keys and card keys and driver's licenses and money in your pocket. And in fact, we can do all of those things with just with a digital mechanism in the future. And so you're ultimately going to want to carry just a little device instead of what you carry today as a wallet in your pocket or purse. And that extends then up through television class devices and then on into the personal computing era. So as we think about the parallel evolution of the personal computer and the television, we're at a point in time where both of these things need to move forward and get better. And I'll talk a bit about how we think that's going to happen. Focusing first on television, there actually haven't been very many technological changes in television other than in its basic form of delivery. It started out as a terrestrial antenna broadcast system, and then people realized, boy, it's hard to get this to work right in the mountains and out where there's a low population density, and so people invented the cable systems and then the satellite systems, all to essentially initially just provide better reception. But once they did that, they realized that this cable system was actually capable of not only just taking the few stations you could get with a community antenna, you could essentially put a satellite feed into it and provide lots and lots of stations. And so actually a lot of the innovation in programming in the last 20, 30 years has actually come from the cable community who had the capacity to deliver more, as opposed to the terrestrial broadcaster who just had one antenna and could only send you one signal. And I think that's an interesting realization, because one of the arguments today about the future of television is whether or not it should just continue to be a single signal that you get. It may be a better picture, but is it just one thing? And the computer industry says, no, it shouldn't be just one thing. It should be a lot more than that. And in a way, we're just predicting that the use of technologies like the internet will essentially allow the future of television to be defined or redefined, just as the evolution of cable as a delivery system ultimately led to the redefinition of television as a service. And we also now see the ability to combine the capabilities of computers and the internet as a publishing medium with the traditional forms of video. So for example, the picture in the top right here, you could say, well, it looks like a web page to me. But in fact, it's a still image of an actual TV show, which is called Pacific Blue. This is a show that's on TV today. Today, when you see it on television, all you see is essentially the video, which is shown in the top right-hand corner of that image. But in fact, that's video that's wrapped in a web page. And the producers of that show have been working with Microsoft to do an experimental version of the show where, if you choose to, instead of just watching the full-screen video presentation, you can essentially see this thing as essentially a live changing web page wrapped around the video. And you have the option, if you choose, to interact with that web page, which is being broadcast as data right alongside of the video transmission. And so we see this ability to combine the best of the web with the best of television. So what we find now is two industries, broadly defined the computer industry and the television industry, which includes broadcasters, equipment companies, and the television set manufacturers. In a way, both of these industries are at a crossroads vis-a-vis what they want to do in the future. The personal computer has essentially moved along an axis that you might say was dominated by the computing aspects and the web and communication capabilities. And it has evolved to be a very, very powerful medium, although one that is technologically very complex relative to traditional radio or television. Meanwhile, TV evolved without much technology injection. As a video delivery system, it's very simple to use, and as a result, people are very comfortable with it. The result of that, and of course a much longer period of evolution, is that 98% of all U.S. households use televisions on a regular basis. And today, only about 40% of U.S. households have personal computers. Clearly, companies like Microsoft and Intel and Compaq and others believe and expect that that number will continue to rise. And really, without any changes, we could, the circle diagram showed earlier, in the next 3 years, we would expect that to rise to probably at least 50 million households, or roughly half of the United States population. But in fact, we want it to go farther. At the same time, the television industry, which has had a very staid technological existence, is at that point in time where, between government prodding and market forces and competition, they're going to have to create digital television. And in fact, 10 days ago in Washington, after a decade worth of lobbying, those new licenses were granted without an auction in order to help bootstrap the United States into a digital television era. But that represents a technological change that is coming at a time that gives us an opportunity to combine these two technologies. But in fact, the two industries have always operated independently. And so there's a great risk to the public right now that in fact we won't figure out a way to bring these together. And that is something that we're working hard to try to do. So if you look and say, what is it that consumers really want? Clearly, they want better pictures. And if you can make the picture better, it's a more compelling experience. It's just like making the audio better. Has allowed people to have more of a home theater capability if they choose to. But we think that they also want this sort of enhanced internet or web access and actually these new forms of video programming. That's clearly true with the young people in our population. They're the people that have grown up with video games and music videos and television and the use of computers in the classroom. And for them, it's second nature to actually watch Pacific Blue, look at the web page, interact with it, all at the same time. It's just, a great thing as far as they're concerned. And so we have to recognize that we have a population that spans quite a range of age and technological comfort. And as a result, we have to provide a new implementation of the television medium to accommodate all of those interests. We also find that people are very, very interested in instant access to the information that's important to them. So essentially the equivalent of news, weather, sports, and traffic information are things that they'd like to get. And in fact, you can see that there must be a need for this or an interest in it, because otherwise things like CNN and the Weather Channel, which just attempt to provide ready access to this information by repeating it frequently, is certainly still only a rough approximation to being able to click on a button and get it delivered to you immediately. And so we think that finding a way to not only allow the computer to be such a delivery vehicle, but the television is also important. And they, of course, like the free market choice that they're always presented with today in both the consumer electronics and the personal computer business, and they like to believe that this stuff will continue to be improved over time. So if you look at better televisions and say, how do we get from here to there? The way that Microsoft, at least, is trying to move there is through the development of a new operating system that we call Windows CE. This was really a baby brother, if you will, to the Windows operating system that people know on their personal computer today. What we recognized is when we wanted to build these new intelligent appliances, that we couldn't actually just take Windows as it had evolved as a full computing environment and try to drive it down into these very, very small form factor, low-cost devices. We really had to engineer something specially for that purpose. And so we did this, and the first product that we put it in was a generation of devices came out last November called the handheld PC. Here we were trying to create a companion product, not for consumer use in the home, but for people who already were business users primarily of personal computers. The idea here was to build an operating environment for these devices that allowed them to be inexpensive and yet powerful, and to have integrated communication capability, because our vision of the future is, in fact, that all of these appliances need to work together and to communicate. And so we also borrowed, in the case of this is a screenshot, a lot of the icons that people know in the personal computer environment and transferred them into this small pocket-sized computer, thereby transferring the user interface with it and making it easy for people who knew how to use a computer to pick up this thing that they'd put in their pocket or purse and essentially, without any further instruction, immediately be able to use it. Now, that concept is one that we want to extend as appropriate into all these other classes of devices as well. And so as we look to where we'll apply this Windows CE as a family of appliances, there are several major categories. The handhelds are out and are already quite successful. We're working with companies to build phones that are essentially internet-based telephony, with a product that Bill's always been interested in, Bill Gates, called the Wallet PC, which is a small device that you'll carry on your person to carry all your digital identification and provide communication through radio all the time. And we're putting versions together with companies that will go in your car to support onboard diagnostics and navigation systems, and ultimately even the entertainment systems in your car. But in fact, one of the major categories is in fact the TV display category. And there are new classes of devices, DVD players, web access appliances for your television, the digital TV of the future itself, set-top boxes for cable and satellite, and even game machines. And there are companies in every one of these categories now that are actively at work using this new operating system in order to build new versions of these devices. So in fact, if you look specifically at this TV display environment, and I'll try to explain a bit about how we intend to take a lot of what's good about the personal computer and the internet and use it to enhance the digital TV of the future. So given that these two industries are at this crossroads, the real question is, what do you take from the personal computer and add to the television to make it better? And reciprocally, what do you take from the television environment and add to the PC? Well, in our mind, clearly now, the trend is to start with the technology capabilities of the personal computer and create set-top boxes and other things that work on television. Now, a year and a half ago, a little company started down in California called Web TV Networks. And they did, in our estimation, the best job ever done in taking a complex computer system sold as a piece of consumer electronics that attaches to the complex network called the internet and essentially masked all of that from the user. And we started working with them last fall, made an investment in them, and the more we got to know what they wanted to do and they got to know what we were trying to do, the more we realized we probably should be doing this together. And so 10 days ago we announced that we've agreed that Web TV will become part of Microsoft. What's really great about the Web TV product is that you go down to the store, you buy it like you were buying a piece of stereo equipment. You open the box, you take it out, you plug in the power cord, you plug it into a telephone jack, and you put it in the back of your television like it was a VCR, and you turn it on with the remote control button. And that's all you do, basically. This box knows how to phone home. And as a result, it doesn't have any of the complexity associated with it. Now, in fact, what it can do as an internet appliance on your television, in a way, is limited still by the poor display capability of traditional television. And that turns out to be one of the key arguments why the computer industry believes that in defining the future of television, you need to have a common display technology between the computer-generated part of the experience and the video part of the experience, so that in fact these things can be combined in a very elegant and powerful way. And Web TV has done a great job within the confines of existing television in bringing the internet to your TV. So what we're really trying to do, if we look at the personal computer part of this equation, is say, well, there's two things that take you a step toward digital television. On the PC side, we've added the ability to do internet broadcasting and the ability to demonstrate this in the form of what we're calling Internet Explorer 4.0, where we create an integrated experience on the computer. NetShow is a technology that I'll demonstrate in a minute, where we're adding multimedia distribution to the internet. Now, in that environment, we have essentially a very small amount of video and a tremendous amount of data that we know how to do. So you can think of that as little v and big D. Now, if you look at the other end, where we turn around and say, okay, let's make the personal computer technology something that would allow all of the future PCs to receive video of the traditional form, whether it's from an antenna, a satellite, or your cable system, and add that with these using the web techniques to enhance the video, you kind of have a big V plus little d capability. And so when we stir all that together and add the ease of use that we think that the Web TV people have done a great job with, you get what we think is the prototype of really the future of digital television, where you have a device that is equally capable of dealing in the video domain or the traditional data environment. So these new TVs will have a number of interesting properties. They'll have much, much higher resolutions than people know today. And in fact, we would propose that the resolution of these would go from today's television, which is an interlaced 480-line system, to a progressively scanned system of at least 1,080 lines. Now this turns out to be a compelling improvement when you have an opportunity to see it. We'll produce these in both large screen and small screen versions, and we'll do it by rapidly introducing new technology and phasing it in a way that it corresponds to the improvement in projection and display technologies for people in their home. We'll have an integrated program guide so that, in fact, instead of having what I call the 6 remote controls problem, which you have today, where every time you buy a box, you get a new remote control. Doesn't look like any other remote control. And as a result, people get very confused and don't even use most of the features of the products they're buying today. So here we have the ability to combine all that into one graphical guide that allows people to control all of the appliances that they use for entertainment and information. And it allows us to essentially make better use of the bandwidth, whether it happens to be over the air, through the cable, or down from a satellite. So if we look toward the question of better PCs, we want to take these ideas and essentially begin to use the powerful new technology that we have continuing to evolve in the computer world and use it to make the PC better. Clearly, the microprocessor is at the heart of allowing this ever more sophisticated software to take place, and also in reducing the cost of these capabilities. It's interesting to look at the rate of change that we expect to continue in this area. Andy Grove, the CEO of Intel, last fall made some predictions about what will happen in the next 15 years in various key elements of microprocessors. So today, in 1996, the typical microprocessor that's being sold as a home personal computer does about 200 million operations per second. And his prediction is that in 15 years, at the same price point, that computer will do 100,000 million instructions per second. The number of transistors that will exist on a single die in order to support that will go from 5.5 million to 1 billion transistors. And the size of logic will go from 0.35 microns to 7,000th of a micron. And that's how we get that incredible density improvement. Now, many people say, wow, what will you do with all that? My Excel spreadsheet is already so fast, you know, it doesn't have to be any faster. Well, Bill Gates has an interesting way of looking at this problem. He says, despite the speed that we have today, and despite the improvements we've made in the software, computers are still deaf, dumb, blind, and clueless. And we need to do something in every one of those areas. And the key to doing it is this kind of technology change. We have ideas about how to write the software to improve those things, so computers will listen to the spoken word. We'll be able to do high-quality voice synthesis. We'll be able to know when you make a gesture or you walk into the room, you know, that it should change or turn on or whatever, essentially endowing it with a limited form of vision. And we ought to be able to make it such that it'll help you more by essentially knowing what your interests are and monitoring what you do and provide greater help. And these all essentially take incredible amounts of computing power. And the good news is we can expect this industry to continue to provide that. If you look at personal computer sales, it's an incredible business on a worldwide basis, and we expect that to continue. In 1996, almost 70 million personal computers were manufactured and sold. And even at those huge numbers, that represented a 16% growth year over year. And we expect that level of growth nominally to continue certainly for the next several years. And that'll result ultimately in probably annual sales of roughly 100 million personal computers per year by the year 2000. So what do you do with this? What makes people want to keep coming back and buying this, and in the future even consider buying appliances that have some form of software-based intelligence in them in the future? Well, as we noted before, people only have a fixed amount of time. And up to this point, the computers in the home and in work have largely been used primarily to improve personal productivity. It's only been recently that we've given them, through the multimedia capabilities, a role to play in providing information access, whether from CD-ROM or the network, or providing entertainment in the form of games, and now this year the introduction of television viewing. But we do believe that people will continue to look for those improvements in their lifestyle and their personal productivity, and that they'll continue to turn to computing-based devices in order to improve that. But if we expect the penetration in households to go beyond 40 or 50%, and we expect in those households to have virtually everybody in the house using these devices, as opposed to maybe just the kids, or maybe just one of the adults in the house, we have to make it a lot easier. And part of making it easy means making it simple and similar from task to task. Now, within the personal productivity area, the graphical user interface created enough of a common model that most people can sit down and use a wide range of applications without a lot of special training. The question is, how do you actually integrate the computer and the network in such a way that they all are presented in one way? And so what we're really doing in the PC later this year is adding many of the concepts that people find to be valuable in the organization of entertainment. For example, the notion of channels on radio and television. And we're using it to allow people to organize the information that they use in their computer or which they get delivered to their computer, such that just as you click on buttons on your car radio, you'll be able to sort of click on buttons that essentially deliver certain classes of information to you on your computer. We also will essentially convert the computer and its presentation to you to be in a form of a web page, so that instead of seeing the computer presented in one paradigm and the internet, if you will, and all those information sources presented in a different one, will essentially give people the option of looking at the computer in an integrated way. The way that this actually happens is, if you look at the left half of this diagram, what you see is the traditional, or even the computer as it works today. You have a computer, it runs an operating system. The operating system may, for example, have the Explorer, which is the way that you happen to view the files and objects that are local to your machine. But along came the internet, and people created a separate program called the browser that ran as an application, was independent of the operating system, and allowed you to go out and see the stuff that was on the internet. Now, what we really want to do is combine those things so that you have the best of the computer plus the best of the web into one integrated presentation. And so this year, in Windows personal computers, you'll begin to see a notion we call the active desktop, where all the functions of exploring the computer itself will be recast as web pages, and all of the functions that the browser performed in the internet will be done using exactly the same integrated mechanism. And as a result, you'll see a more seamless integration between the traditional computer experience and the web. Here you see on the left the way people would see a Windows personal computer today, and on the right a web page. But in fact, what we're going to do with this active desktop is take some of what was good, for example, the map that shows you where all the things were on your computer, and apply it to the web, so that when you go to a site that you happen to get to by following a link, you could then actually know where you were, for example, within that company's set of information. And on the other hand, we're taking the entire computer and presenting it to you as a web page that you could even customize. And you just click on the links that are on the web page to take you down and provide more detailed information about the elements of your computer system. Now, what this does, especially for people that are not already personal computer users, is in fact they never have to learn about dealing with the computer up to the point of its evolution this year. They can essentially start and just think of the continuum of the computer and all the information they can see through the computer presented to them in one very, very simple form. This allows these new user paradigms to occur, where whether it's at home or at a corporation, people can essentially lay out a desktop that, instead of just being the icons that allow you to run programs on your machine, actually represent the ability to run programs, see stock tickers, watch video, and have links that you click to go out and find the information that you typically use over and over again. And this information could exist local to your computer, or in fact could come from anywhere in the internet. If you look at the evolution of multimedia, we started out and added it to computers and used CD-ROMs to deliver it. But really, it's a lot more convenient if you can get that high-quality multimedia delivered to the network. And so Microsoft has taken the technology originally developed to support interactive television, where we deliver an individual television program through a cable to every single television separately. And we've built versions of it that people are starting to use this year in the internet and in corporations to deliver video over these various speed networks. And we're using the more powerful computer systems in order to do this, even at very low bandwidths. What I'd like to do now is just show you a very brief demo of a couple of applications, prototypical applications that people are doing with NetShow. And what I've shown you here is an Internet Explorer standard product with a web page constructed in it. And the links in this case on the web page are actually pointers to different speeds of applications that use different speeds of communication. Now here I'm actually driving all this for convenience tonight off of a CD-ROM and using the computer to simulate different levels of performance. But what I'm trying to convey to you is that many of these techniques apply whether you're dialed up over a local phone line, connected on a local area network, and you'll see are only a short distance away from what people call today full motion video on television. So first I'm going to go to a web site of a hypothetical record company who wants to use the internet to merchandise their music videos. But they recognize that most people can still only dial up over relatively slow speed links. So here I could show you 28.8 dial-up, or if you happen to have, let's say, an ISDN line, you might, when you came to their website, you would essentially click here for the higher speed one. So I'll just show you that for a minute. And what you'll see here is a concept we call illustrated audio. It's like a slideshow that has a full audio track associated with it that essentially plays itself. Now what you see here is pictures and moderately good audio, not yet CD quality, but you got to realize we're doing this at a tiny, tiny fraction of the bandwidth that comes off of a CD drive or a CD-ROM drive. And people are able to take images from the video or the materials that they're trying to merchandise and essentially pass them through the network. And here you have the ability to use all of the power of HTML-based page authoring, scripting, etc., and along with it, streaming media. So this music and these pictures actually never get stored on my computer. They actually just stream down the wire and are displayed in real time in the middle of this web page. So we'll go back and show you what happens if we change the speed of the network. So I'll go back here, and I'll go down here to an example of a training film. This is a bit of a humorous one that we put together for a hypothetical Seattle coffee company. But here the assumption is that I have a 1 megabit per second bandwidth that I'm willing to use on my corporate local area network. So that's essentially 10% of a traditional Ethernet connection in business. And what you see here is essentially
Hi, can I help you?
Yeah, okay, look.
a web page
I gotta tell you,
with full motion video
okay,
on
I'm a
it.
little nervous now.
It's okay.
I grew up in Seattle, spent my whole life here, but this is the first time that I've ever ordered any coffee or anything
Okay.
from one of these guys. I see these carts
Okay.
all over the place, and I know it's like a big
All right,
guy.
all right, just
I hear that
relax, okay?
So I'm really
Just relax.
This is
Okay,
my
just
first
relax
time.
a little bit.
You got to be gentle with
Okay,
me.
okay. We're going to walk you through it. It's going to be okay.
Okay, good.
Okay.
Okay.
Have you had
Now,
any
in
coffee
fact,
today?
I've had just a little bit.
What you have here is a web page,
But I just need a little more.
Okay, we should give you enough to make
Okay,
them
okay,
stop
yes,
filling
but
up.
and I could actually click on these links on the web page,
Okay,
and
now
while
how
it
does it all work?
continues to
We're gonna
play
start it with the
video,
foundation, all right?
Okay.
All coffee
it'll go off and change it. So in fact, this is a training
Let me
film
explain to you.
for
Wait a minute, I
people
thought this was
who
all
want to
true.
learn how to make the various forms of coffee products.
Here, I'll show you.
And they can
All right.
understand what they might encounter in terms of the customer. They can understand the different products that are available, and by clicking around on this web page, or in fact clicking on the video itself when they see something they want to learn more about, it actually will take you there. So this looks like a web page, but it actually has full motion video, it's indexable, and it's controlled just by clicking links around here as you would in any other web environment.
Espresso.
Okay, that is an espresso.
I thought you said that was a shot.
Okay. Hang with me here. A shot and espresso are the same thing.
I see. Okay. My gosh, that looks so strong with all that, just that little bit there. That's
Yeah, it's like a diamond.
That's a little.
Just
boy,
like
that's
a
little
diamond.
too strong for me. Let me try something else. Let me try this. I'll have a late.
For what?
No, a late.
I can make it as fast as you want.
No, it's a cafe.
When I show this to people, the question that I ask them, at least rhetorically, is, how far different is that than television? Well, it isn't very different. And in fact, for what we predict will become the television of the future, it's not different at all, other than the fact that this is working on a much lower speed network. And so as we propose to have satellite systems and new digital TV systems and cable systems that actually work using digital technology, then we have the ability to use this kind of technology to implement anything from traditional high-quality TV programming down to this kind of thing, or even the ability to merchandise using multimedia on the web. And that's what makes us so confident and to some extent adamant that it's important for the public that we build the future of television in a way that allows the ability to combine computers and software as well as traditional TV programming. Now, if you actually have any technological bent, then you realize that when you look at this web page and say, what was really going on here, there are documents that essentially show up as HTML pages. There are controls that allow things like full motion video to be just dropped by the author as an object on that web page. So they don't have to do any programming. They don't have to know anything about how the computer works. They can essentially be more like a producer, and they just take graphical things and they drop them on the page, and the computer makes them show up as video. If they want to do a little scripting or have some people who know how to do some programming, then they can increase the level of automation, just as is happening with web pages today. At the other end of the wire, we've also realized that in the future, it will be companies like the people who run your cable systems and television systems and network systems that have to provide this information in the future. And so many of the things that are used to run networks today, telephone networks, television networks, are essentially finding their way, again, using this same web-based metaphor for operation, to allow people without special skills in computer operations or programming to use this technology to provide these new mediums. So the next step for us in making the PC better was to take all these things that are good about television as we've known it, and all the different high-speed delivery mechanisms, and add them to the personal computer. And so we have just announced that, in fact, this new architecture called the broadcast architecture for Windows, we've decided to make a standard part of every Windows operating system that Microsoft sells starting later this year in 1997. Now, the net effect of that is that all PCs that are sold as new computers, and for those people who choose to buy an upgrade product, will be able to begin to have television capabilities, even current television, on their computer. Now here, though, we've actually given the ability of the computer, to the computer to not only connect to the internet and do the things I've just described, but to plug in a satellite dish from DirecTV, for example, plug your cable system in, or even an antenna from your terrestrial broadcaster, and have them all integrated into one common viewing environment. So we do this by essentially thinking of the pipe, the digital bit pipe that the bits come across, as being part for video, but also part for data. And that's a very radical change from the people who originally started out thinking that the future of digital television was just to send digital video. And if you think about boxes, again, like personal computers or the web TV class of appliance that has an optional phone connection, then in fact you've got the ability to have a closed loop system, or what I showed earlier as a mid-band system, where you use high-speed digital transmission down to the home and then have, if you want, optional interactivity even using existing telephone wires. So these represent a very potent system to begin to move people toward this new digital age. But as we look forward and look at the behavior of the consumer and try to understand the issues, there are certainly a few cautious notes that get sounded. One, when we look at household penetration and we see it getting up to 40% and without change perhaps 50%, we're still a long way away from saying that these computers are freely and readily used and available to everybody in their household. We see people frustrated and churning away from some of their online services or their internet service provider because, in fact, it's either too complicated to use or it's not always available. They get busy signals. So as the popularity has increased, our ability to engineer systems that up to this point have kept up with the demand has not been very good across the industry. And of course, many people think that the products today are a little too shallow, that there's either not enough information or they don't provide all of the services that they're looking for, and they tire of them fairly easily. So all of these things are things that we think that we can fix and are in the process of fixing. But in fact, we have to fix the platform a little bit in order for that to happen. So the computer industry, at least people at Microsoft and people in other companies that work with us, are very aggressively moving forward on initiatives, for example, called the Simply Interactive PC, where we make a device that is purchased more like an appliance. It isn't as configurable, but as a result, it basically is a lot more like buying a television or a stereo component than buying a general purpose computer system. And we are adding things like Instant On, so people who are frustrated by saying, well, I don't want to boot my television, don't have to face that problem. We've already solved that, for example, in all the Windows CE appliances. There is no booting process. You push the on button, it's on instantly. You push the off button and it goes away. And things like web TV show that there are implementations that appeal to consumers for information access on their television where, in fact, you can hide all the complexity of the computer and the network. And we are using the PC software that we've already evolved in special ways in order to do that. So other elements are also improving. We have technological innovations in all these other areas in addition to the faster processors. Within the coming year, we'll see radical improvements in the video and graphics subsystems that are available in computers. We're seeing very, very rapid increases in the size of mass storage that's available and a reduction in cost. Memory prices have finally declined to a point where they're not a dominant factor in the cost of computer-based personal computers or appliances. And perhaps in this question of television, one of the most important changes is going to be the introduction of new flat-screen technologies. Today, all the personal computers and TVs are still dominated, for the most part, by the traditional CRT or glass tube, picture tube. And it's an expensive technology and one that doesn't actually get better at the rate that silicon improves. And so a lot of the new technologies, plasma panel, digital mirror display devices, and LCD panels, which you can see in limited applications like in laptop computers today, are going to become very, very widely used in consumer electronics and are going to be able to reduce the cost and increase the picture quality of all these devices in the future. The Simply Interactive PC is a vehicle that allows us to have a simple, interactive, sort of engaging platform in the home where you can create a center for entertainment, communications, and productivity. And so to do this, we actually have to make one other change, which is to create a common graphical guide that people use for the entertainment and information services on the PC and the television, so that that experience is common, whether you happen to watch it in your study on a little screen, watch it in the family room on a big screen, or watch it anywhere else. We think that the combination of the better personal computer and the better television actually does enhance the experience in the home. You'll have instant accessibility to information available through the World Wide Web. You'll be able to have smaller, quieter form factors for both personal computers and these intelligent televisions. We'll provide easy external expansion so that instead of having to open up your personal computer, it'll be more like buying another modular stereo component. You set it next to or on top of the first one, plug it into the last one you bought, and you won't have any configuration efforts to do. We'll be able to take the best technologies evolved in both the video world of television and the graphics world of the computer and bring them together in these new devices. And of course, we've already succeeded in putting high-quality audio systems and to allow all these things to work together through networks in the home. The way we do this, essentially, is to continue the process we've already been doing for quite some time. In a way, for those of us that are close to it in the industry, the PC is an amazing device. It just continues to morph to meet the requirements of new applications. It started out as a fairly simple device, and now it has evolved into several special categories. The kind that people use at work, the specialty implementations that are becoming the mission-critical servers, both in offices and on the web, the ability to have home personal computers that are now being broken down into both the ones that you'd have in your study for productivity applications and also the new class of entertainment PCs that have 35 and 40-inch screens on them and are really being bought as television systems and entertainment systems, not strictly personal computers. And now, through the Windows CE effort and the involvement with consumer electronics companies, we have all these new form factors of the television, the web on television, handheld computers. And we think that these evolutions will continue. So why combine the digital television and the personal computer? One, we think that doing so will ultimately improve picture quality and the user interface will get better. We can transform the TV experience and to some extent reinvigorate the viewer, which is important actually if that medium is to continue to be an advertiser-supported one, at least for over-the-air broadcasting. We can give broadcasters and advertisers new business opportunities where they could essentially sell subscription services to data sources or perhaps secondary camera views that, during the Super Bowl that they might not otherwise be able to see. And we can expand the distribution channel for all forms of intellectual property products that can be created into digital form and actually delivered through the internet. It's interesting to look at how this evolution has been different in the world of computers and television. On the left side of this, you see the timeline starting in 1941 and extending to 1997, where in fact in 41 we created television. In 1953 we actually defined an enhancement called color television, but it took 20 years before that reached any kind of significant scale use in the United States. Why? Because there weren't enough of them out there for people in the content community to decide they wanted to spend the extra money to create color TV programming. But of course, if there wasn't any color television to watch, the consumer wasn't very inclined to go out and pay money to buy a color television. So in every form of consumer electronics, you always have what we call the chicken and egg problem, where you're never sure which one is going to go first. And the computer industry, I think, is at a point where, as we have this chicken and egg problem with the launch of digital television, we can essentially solve part of that problem. Actually, as we went on beyond that, in 1981, the government, largely due to the arrival of a proposal from consumer companies in Japan, formed a panel to define digital television in the United States. It started over 3 times and finally produced its recommendation at the end of 1995, 14 years later. The personal computer industry started the same day, all right, with the launch of the IBM PC, and everything you know as the PC, Microsoft, Intel, Compaq, and 400 other companies basically has all happened while they wrote that spec. So, unfortunately, that creates a situation where the computer industry thinks we have some great ideas, as I've demonstrated to you, about how these things should be blended together to define digital TV. Unfortunately, the TV industry set out and achieved their goal of producing a digital way of transmitting traditional television programming without any real notion of how it would be combined with computers. And so we find ourselves at this crossroads trying to figure out how we combine them. So Microsoft, with the computer industry, has taken the initiative to basically create this family of Windows-based platform products that start with the small television-based Windows CE things, extend through enhanced television appliances, and then give you family room and living room personal computing, all with a common user interface, and all of these things with the ability to do both video and data applications. It's interesting to look at the forecast as this happens, and you see more and more of these in the home. In 1995, television hours spent in the home overwhelmed the number of hours that people spent with personal computers. But it's predicted right now that in about 10 years' time, we'll find that in the various forms of computers that I just showed you, people will actually spend more time with those interactive devices than they will in front of a traditional passive television. This is achieved in part by creating a dual-mode broadcasting model where we're able to take the benefit of the two-way internet, kind of the arrows on the top, and link the broadcast world to the personal computer, and to take this powerful visual computing platform that's emerging both as a PC and a TV and feed it broadcast signals, both for video and data. And as a result, we have this hybrid system that helps to bootstrap this new process. The result is you'll end up with some kind of personal computer or personal computer derivative product like an intelligent television at a whole range of price points, from very large sort of PC theater class systems down to true digital TV appliances. And we think that this can actually happen in a relatively short period of time. As I said, one of the reasons we think that we can help this process is that people are buying these computers for other applications as well. And whether they use them to watch television or not, we're going to sell probably somewhere between 10 and 20 million of them in the United States next year. That's in contrast to the television industry, who, if they launch according to the current plan, would sell about 100,000 $5,000 televisions in the United States in 1998 and 1999. So we think that people will actually find that the PC is a more prevalent device to begin to look at both the entertainment and information applications on in the years to come. So the way that we're doing this is essentially taking and adding to Windows both the Memphis release, which is about to come out, and later in the year the Windows NT release, this new broadcast capability, such that we're doing everything we can to ensure that all the personal computers are capable of this as time goes on. So what this does is it allows us to deliver the TV experience in Windows, which we think, as far as the consumer is concerned, will be a major step up in terms of the usability and interest in the personal computer in the home. It allows digital video and data to come from broadcast, satellite, and cable. We think that we'll have 40 million so-equipped personal computers sold by the year 2000 in the United States. And as a result, we think this is the most direct and cost-effective route from the entertainment PC to the full-fledged digital TV systems of the year 2000. To do that, Compaq, Microsoft, and Intel have banded together really to offer the industry, the computer industry and the broadcast industry, an alternative to the original proposal. We negotiated this right with the federal government last year and in fact blocked the normal process that would have put into law just before Christmas last year a specification that didn't actually include any of these internet and intelligent television capabilities, and in our mind would have locked the American public and largely other elements of the world population into a very static standard for just better pictures, when in fact we think there's a lot more that can be done. So sorting as what we call the digital television team, we formed an affiliation of these companies to put together a proposal and work with the consumer electronics industry, the PC industry, and the broadcast industry to see if we can interest them in this accelerated way to get to digital television. You can read in the newspapers that that's a bit of a controversial proposal, but nonetheless we continue to move ahead and have recommended to all the personal computer manufacturers that they introduce this system into PCs in calendar year 1998. As a result, we'll get these high-definition capabilities, large and small screen versions, and we'll implement them in a variety of these PC and TV systems. When you look at what has to happen for this to occur, there's a lot of work that has to go on in the production area, and largely our proposal doesn't affect that much. We also wanted a system that not only worked for terrestrial broadcast, which has been the historical focus of these new systems, but worked equally well with satellite, cable, and internet-delivered content. And we wanted to have a common experience in the television and personal computing environment in the home of the future. In order to do that, what we did was focus on what we thought was the problem area in the middle of this chain from production of the content to the consumption of it in the home. Really what we call the broadcast phase. What we wanted to do was give people a specification that allowed the digital transmission of this information in a way that was friendly to computers, as well as providing better pictures for TV. To do this, we actually took some of the technology that was originally proposed by the broadcast community, shown here as this map, and basically all the things that are marked as X's in green are the elements of that original proposal that we've used to create the base level capability for digital television. And what we intend to do is to use the same techniques we've always used in the personal computer industry and the scale economics of the worldwide computer industry to, year by year, lower the cost of that capability and ultimately add, in an upward compatible way, higher and higher resolution capabilities. And so our expectation is between now and roughly 10 years from now, we would be able to, in a compatible way, upgrade digital television from something that's at least 2 or 3 times visually as good as you know in television today to something that is essentially movie theater quality in as little as 5 or 6 years. And as a result, you'd be able, if you wanted to buy screens the size of the one you're looking at here and see pictures at this quality level at a minimum or higher, in a compatible way on both PCs and TVs. And so our goal is to make, through the combined use of hardware and software techniques, all personal computers shipped by the year 2000 that are capable of being digital TV systems. And at the same time, to make that technology and the software available to the world's consumer electronics company and encourage them to build intelligent televisions that conform to this same specification. And if we achieve this, I think we will see the beginnings of a new world standard for television. It'll emanate from the work that we've done here in the United States in semiconductors, computer systems, and software, and I think will be the basis for a radical change in the way people get information, communicate with each other, and get entertained in the future. So this basically completes, in our mind, a very rapid technology cycle, or internet technology cycle, that began with the creation of the personal computer, that evolved to provide the technology now for mission-critical servers and the broad deployment of this in the internet. As people began to realize that the power of the computer came from hooking them together, we took networks and wide area networks and began to use them to interconnect these machines. Then they weren't fast enough, so people have gotten creative and tried to come up with things like ADSL, or digital subscriber lines, and cable modems to ultimately be able to have consumers in their home have high-speed access to all of these both communication and entertainment systems. We've looked to the future where we want to take, for example, technology like ATM, which is not automatic teller machines, but asynchronous transfer mode communication technology, and use it to further improve the switching capability of the public networks. Then we've taken personal computers, put big screens on them, and essentially sold them into the home as the center of entertainment appliances. That's all happened this year. And now we're taking this technology and putting it in appliances, set-top boxes, DVD players, game machines, and in the future, digital telephones and televisions. And then recognizing that you're really moving to an environment where people want to consume this not just at 18 inches from the screen, but like they do 10 feet from the screen with their remote controls. And we've added the other peripherals necessary that people have learned to have in game machines and remote controls for appliances, and essentially brought them to the world of personal computing, thereby giving people a very, very simplified experience, even though you have an underpinning system that is actually very, very sophisticated. And so with this, we think that we're really at the beginning of a new age of entertainment and communication, and we really are looking forward and very excited about it. So with that, I think if we have a few minutes, I'd be happy to entertain a few questions. There are microphones in the center aisle if people want to ask any questions. Yes, sir.
I was wondering, what do you think? How do you think the network of the future is going to be implemented? As far as, I saw a person holding a bundle of fibers. Do you think it's going to be fiber optic ATM transmission, or?
I don't think there's actually going to be just one form of network. In fact, the costs are so high and the time frame so long that I think you'll see many different technologies used. I think today you'll see the backbone networks and essentially the distribution that gets the bits close to your house, but not all the way into your house, done on fiber. And then beyond that point, people will try to reuse some of the coax that's there or the twisted pair copper that's there in order to reduce the cost of construction. And so you'll probably see hybrid networks in the future.
But do you think that's going to have a high enough bandwidth to enable video and sound transmission?
Yeah, that kind of hybrid network will actually support probably a delivery of over 30 megabits a second to every house on a unique basis. And that's more than enough to do high quality video and audio.
Yes, Wintel is certainly a very powerful force today. you're talking about combining computers, PCs specifically, with television. There's another force too, not as strong, but the network computer with Sun Microsystems and Oracle. If that does come about, how does that affect combining television with PCs?
Well, I guess there are a number of issues vis-a-vis the network computer. Certainly Larry Ellison, Scott McNealy, and the people who are advocates of that system design believe that they could find both residential applications of that and workplace applications. There are some things that we actually think are not particularly desirable about the proposal of the network computers. Some of them essentially only work in a connected environment. Now you might say if I had a high bandwidth connection to the home that I could use that, but today there really aren't any high bandwidth connections to the home that work in a bidirectional way. And so that'll limit the ability of that particular technology to find short-term application in these areas. In fact, you know, Mr. Ellison at Oracle, who did that, his groups had done a lot of the same work that my group had done in creating interactive television technology. And he chose to take that forward and create this network computer concept. We've essentially used that to define the Windows CE technology and to work to define a broader array of products from the small handheld devices all the way through the multimedia and PC class. And we ultimately think that we have a broader product family and it'll find broader applicability. There may be some use of the network computers in both places over time, though. We think it'll probably end up being small.
Thank you.
These are dazzling possibilities at a breathtaking rate of development. What are we going to do with the megatons of obsolete equipment that come out of this?
One of the things that we actually are quite sensitive to is the technological obsolescence that is created here, and the recognition that particularly in some of these appliance categories, consumers, you know, may not be happy if the thing obsolesces too quickly. One of the things we actually liked about web TV and the way that they engineered their system, and one of the benefits of having this end-to-end capability, is that they update the system automatically without the involvement of the user when the thing phones home at night to see whether you have any email. So as they add features and find more clever ways to do things or add new capabilities in the internet, they essentially download that into the computer automatically. And I think that that kind of management of the appliance and management of the personal computer will become much more prevalent both in the office environment and in the residential environment. And that'll tend to both improve the simplicity of use, lower the total cost of ownership, and actually wring more out of the products that people buy. And therefore, you know, we may not see the same rate of obsolescence that we have in the past.
My question is more in the use of this technology and the application of buying or shopping on the internet or on the web TV, and that the technology seems to have kind of outstripped human nature, at least in the interim, in the sense that it's kind of outpaced our habit, and buyers rely on their habits to go out and buy things that they buy every day. Do you see or do you perceive that the technology will have the ability to teach people to use this technology to their advantage?
Is your question, will the technology help train people so that they know how to use it better?
Right, because a lot of people right now can see the advantage of possibly banking on the internet, but what about purchasing services or purchasing products?
Well, I think more and more people are moving rapidly to do that. I mean, I showed you the Expedia example, you know, where in a period of 90 days, where there was no comprehensive travel service on the internet, you now have tens of thousands of people that are shopping for airline tickets and hotel rooms and car rentals through this mechanism. Nobody trained them how to do that, right? There was no instruction manual. You know, all they did was go to the web page and by clicking on a link somewhere, and they just started, you know, pushing on the buttons. The thing that's very, very powerful about this hypertext or page and link metaphor is that people of all ages seem to be able to intuitively understand that. The reason that seems to be true is that people tend to operate on a free association basis. When you pick up a newspaper, you probably don't start in the upper left-hand corner and read, you know, down every column and then turn the page and read the next one, right? There's links all over that thing, you know, that you know, little indexes and things that tell you to go to different sections. And you do that because it's the way that you tend to think. And the nice thing about this page and link model is that as you read things and you get stimulated, the link is right there. And if you want to follow that link and free associate on it, you just click on it and it takes you there. And because you have this notion of being able to go backwards and forwards in this navigational model, you can do what you do with a book or a paper. You can go follow the link. If it was interesting, you can go farther. If it isn't interesting, you go back where you were. And I think that is so simple. And that's the reason that this internet has exploded in growth, is you don't have to train people in advance.
Do you think it'll allow them to change their habits?
I think it already is changing people's habits for those that, have access to it.
You talked a lot about future Microsoft innovations. What do you think is the greatest original innovation for Microsoft up to this point?
What's the greatest original innovation?
Yes.
Well, I don't know. I've only been there 4.5 years. They probably did a few interesting things before I got there. I think, there have actually been a lot of things that the company has done in the area of user interface design that is quite good. Most people don't really understand how much engineering goes into that. Somebody asked me at a presentation yesterday about what we were doing to support the ability of young disabled children, to use these computers. And in fact, Microsoft does an incredible amount of engineering that to the average person is completely invisible, to allow all the different forms of disabilities to not be an impediment to using the computer system, either with other aids or not. And so I think, there's been innovation in this company in a great many areas. And I actually like to think that the work we've done in these broadband networks and in being able to figure out how to merge television with computing are going to be shown to be very, very important innovations. And many of those actually are coming from Microsoft, even in the areas of defining how the computer architecture and graphics architecture should be done.
Thank you.
You mentioned standardizing of mode of data transfer, and I was wondering what you were thinking of the brand new 2 technologies that are competing in the 56 modem category.
Well, actually, the work I've described here is for the most part agnostic relative to the particular transport involved. So we don't care whether it's satellite, cable, telephone, or wireless. So 56K is sort of just an incremental improvement of the modem technology for dial-up access. I don't think that actually represents a compelling improvement. I had, ISDN in my home, which was twice as fast as 56K for 3 years, and while it was certainly an improvement over 28.8, it isn't anything like what I have today, where I'm one of the experimental users of a 6 megabit per second ADSL service in my home. And that does, in a very dramatic way, change your experience with the use of these technologies.
Okay, thanks.
I have 2 questions. One is a computer novice. Should I throw away my Apple computer? And the other one, it seems like you've been talking about refinements of the technologies that have been discovered in the 20th century, radio, television, computers. I wonder if you can look into your crystal ball and think about any future technologies that we are perhaps just now contemplating as far as communication.
Well, as far as your Mac goes, that's your personal choice. One thing that I think is clearly true, this industry is an unforgiving industry. And it's unforgiving because it's highly competitive and it changes at an incredibly high rate. And so, right now, like it or not, Apple has some serious problems because they made certain business choices that tended to isolate them from, large forces that were happening around them in the industry. And as their market share has declined, their ability to be a force with the content community similarly starts to decline. And so they're at a critical juncture, and so they're trying to make changes. Microsoft loves Macintoshes. We are the largest provider of software products for the Mac. Most people don't know that, but we are. Most people use Word, Excel, and PowerPoint on their Mac, and they get it from Microsoft. Without that, I think that the product would, have had even greater problems. So it really is a choice in terms of the company that you want to buy from and the operating system that you want to use and how many manufacturers you think you want to have a choice from. Right now, many people are electing to go with Windows-based PCs simply because they have greater choice and lower costs. As far as gazing farther into the crystal ball, the things I showed you tonight are a fairly good, projection compared to, most people's thinking about what's going to happen. I do think in the comment I made that where Bill challenges us to fix the fact that the computers are deaf, dumb, blind, and clueless, that in itself is probably the best forecast I can give you for the next 5 to 10 years of where you're likely to see radical changes in hardware and software techniques applied to the problems of voice recognition, natural language processing, computer vision, those things, and essentially making the computer a better partner to you in the tasks you want to perform.
One of the major promises, I think, of the internet was many-to-many. And I notice you haven't talked too much about that. How do you see many-to-many communications fitting in with this picture that you've painted tonight?
Well, if you think, I guess I need to understand what you think by many-to-many. If you are talking about how could we have essentially a conference call with all of the people who are in this auditorium tonight, where they all got to participate equally, I'm not sure that's a very interesting, process. If you're talking about simultaneous communication. Now, actually, the things I did show you tonight have the ability to allow small groups of people or a presentation like this to be viewed, even interactively through the internet in a one or small group to many kind of environment. Technologically, there probably is the promise of allowing a large community to participate in an event together with some limited form of interactivity. But I mean, as you may know, even if you tried to do a video conference, if you try to essentially expand that group, to one where there are just more than a handful of simultaneously interacting people, it's like being in a room like this or at a cocktail party, right? At a cocktail party, people, they don't talk to everybody. They have to find some local group to communicate with just because it's not possible to operate any other way. So I'm not sure it's a great answer to your question, but I think
more or less just higher bandwidth individual conversations or something, but that would still be possible through these networks, or would these networks exclude one-to-one or one-to-two or two-to-two?
No. I mean, basically, person-to-person communication or small group communication are already supported. In fact, you can go to Microsoft.com, download NetMeeting for free, and essentially have a internet-based capability for meetings, including voice communication, video communication, chat sessions, whiteboarding, drawing, and application sharing, all in a single program. That technology exists today on the internet.
And the channels will continue to support that, in your opinion?
Sure, they only get better, in fact. I mean, today, your ability to do that is limited by the bandwidth of the dial-up telephone network for most part. And when you start doing that in higher bandwidth networks, in local area networks in corporations, or in a higher speed public network environment, it gets much more powerful. Okay, last two questions.
With all the connectivity we have today, I'm kind of interested how it's going to affect the software application industry, is my first question. And the second is, how are these companies going to generate revenues? In other words,
you mean
one of the things I see is people, and they're doing it now, download an app. There's more accessibility right now. Say, for instance, if I want to buy an operating system, you go into the store and you hand the guy the credit card or the money. But now we've got these big pipes, and I don't need a marketing channel to develop and market my product. I do to some degree, but there's more openness. So how, is Microsoft thinking about these things, how it's going to affect them in terms of applications?
Well, sure. I think that the generalized answer to your question is the internet as a medium has a tremendous potential to disintermediate, the current retail distribution channel. I mean, today, you may have a product and you'll give it to a wholesaler who will give it to a retailer who will sell it to you. And each step in that chain, people tax that product and the cost goes up to the end consumer. In the network environment where you can, you know, if you were 2 Hip Records, the one I show, you say, hey, I make those music videos, I put them up on the web, okay? You want them, you come to my website. If you want it, I'll actually deliver you the bits over a high-speed pipe, all right? I don't even have a media that I have to print and deliver. So in that environment, you could say that that company disintermediated both the wholesale and retail distribution channel if they choose to do so. Now, it turns out that I think each company has to decide what it is they're really good at, and that there probably still are, even on the net, opportunities for aggregation and distribution for all the reasons that they were in the physical world. But I think that it really does have the potential to radically change the business. So when you look at companies like Cisco, who are selling major corporate accounts, their switches and routers, they just click on the web page and order another one like the one they have. I mean, at that point, they eliminated the cost of the sales call, they eliminated the printed brochure, the order paper, and everything else. And, you know, the computer basically puts an order in the factory and goes out the door, and the guy gets it. Companies like Dell are doing a huge amount of their business in selling computers to residential customers by just having them click on a web page, configure in the computer they want, they push the button, send in their credit card, and boop, away it goes. And so these things have a tremendous potential to make businesses more efficient and the distribution chain more efficient. And I think that that applies both to companies who can fulfill their product through the web or companies who use, you know, external physical world fulfillment mechanisms, but take the entire merchandising and ordering process and essentially collapse it down.
Do you think it'll open up the market or close it more?
Well, I actually think it'll open it up quite dramatically. I mean, the number of the cost of entry, you know, is much lower in the internet than it has ever been in retail distribution. And the reason is, you know, within the limits of your marketing capability, there's unlimited shelf space. All right? I mean, the biggest problem in retailing is shelf space. I don't care whether you're in the grocery store business or the software business, there's only so many inches on that shelf, and people fight to get their products on those shelves. And when you're out of shelf space, you know, you're out of business. And in the internet, you sort of never run out of shelf space. The problem is that the shelf, it's like walking into Walmart, though, right? You say, whoa, look at the size of this place. You know, if you don't know what you're looking for or where to go get it, you know, you may not be able to find it to buy it anyway. And so that's where you need to have new tools and the use of the computer itself to help guide you to the things that you want.
Thank you.
You've had enough. Let's go to the next one.
Since the beginning of the industrial age, no company that has dominated an industry in the next paradigm technological shift has dominated the next shift. We have most recently, for instance, seen that with IBM, which dominated and then fell away under the personal computer. It looks like it's starting to come back under the internet. What is going to make Microsoft an exception to this rule?
It's people. I mean, it's really just that simple.
Yeah.
Okay? I mean, you know, if we do a good job, you know, we will do everything we can to try to continue to succeed in the next generation. Bill Gates has spoken openly about the fact that, you know, that most companies get big and successful and they lose the will to succeed, you know, in the next generation because it requires change. I contend that Microsoft last year demonstrated an agility for a large corporation unlike almost anything that's ever been demonstrated before. When Bill said, okay, folks, the internet has arrived, we're going to go take advantage of it, everybody go do the internet. And in 1 year, basically everything in the company turned around and took advantage of that.
That's right, but the thing is that that means that the people at Microsoft were not thinking about some of these problems for a long enough period, and they came up with architectures like ActiveX, which has some very fundamental underlying flaws that cannot be corrected. And, you know, you haven't spent the time thinking about it, and now you're reaping what you've sown.
Well, but it's always been that way. I've been in the computer business 25 years. And I never met the computer designer yet who didn't end up not putting enough address lines on the memory system. So, I mean, it has never really been an impediment in the computer industry because we fix the problems as we go forward. And yeah, we live with the sins And we recognize that there are sins, but that doesn't make us feel bad about what we've achieved. Last question.
The last question is, I'd like to congratulate Microsoft on the good earnings report today, and thank you for helping my retirement fund.
You're very welcome. Thanks a lot.